Welcome to Monthly Math Moment, the web series where we take a quick peek into the modern elementary math classroom. I'm your host, Amanda McIntyre. As we round out our conversation about how we make student thinking visible using models, we're going to look at two very closely related models that are used to illustrate multiplication and division, the array and area models. When you hear the word array, you may think of a big field of solar panels or a market with a wide array of fruits and vegetables. The word array literally means a large group of objects, often organized. In math class, we think of an array as a picture that has equal size rows and columns in it. Arrays are a powerful tool used to help students make the jump from thinking about addition to thinking about multiplication. At the start of third grade, we use an array to help students see multiplication as repeated addition. Let's look at an example. If Mrs. LaFrance is meeting with a group of families and she puts out 6 rows of chairs with 5 chairs in each row, we can draw her chairs as dots in an array like this. Then when we go to count the dots, we don't have to count each one. We can count 5, 10, 15, 20, 25, 30. She set out 30 chairs. If we wanted to write an equation to match the drawing we just made, we could write 5 plus 5 plus 5 plus 5 plus 5 plus 5 equals 30. Or we could be more efficient and write 5 times 6 equals 30. This is how students start their understanding of multiplication and division at the beginning of third grade. Up until that point, everything has been addition and subtraction, so we build on what they already know using arrays to model it. As students become more familiar with the layout of rows and columns, it allows them to draw pictures much more quickly and to see what's called the commutative property of multiplication. For those of us who are not in math class all the time, the commutative property says it does not matter what order we multiply numbers, we will end up with the same product or answer in the end. So let's go back to that example with Mrs. LaFrance and the chairs. If she put her chairs in 5 rows of 6 instead of 6 rows of 5, her array would look like this. So she would still put out 30 chairs. Therefore, we know that 5 times 6 is equal to 6 times 5. Arrays are a powerful way to visualize multiplication in the early stages of switching from adding to multiplying. That said, an array is not a very efficient way to model really large numbers. After all, that is a lot of dots to draw. So towards the end of third grade, students are introduced to what is called the area model. An area model takes advantage of what we know about how to calculate the area of a rectangle. A rectangle has an area that is really just a fancy array with equal size squares in rows and columns. We just don't always draw in the squares. By using an area model, we're able to break apart seemingly tricky numbers into easier numbers to work with. Let's look at a third grade example with 4 times 7. Using an area model, I will start by drawing a rectangle that represents 4 units by 7 units. 7 is a tricky number for me, so I'm going to imagine I can cut the rectangle into 2 rectangles, one with a length of 5 and the other with a length of 2. I chose those numbers because they're easier for me, and I know that 5 plus 2 equals 7. Now I can find the area of each of the rectangles. 4 times 5 equals 20, and 4 times 2 equals 8. Once I put the 2 pieces back together, I'll have the whole area of 28. So 4 times 7 must equal 28. This is the start of what is known as the distributive property. The distributive property of multiplication says that I can take one of the factors and break it apart into smaller numbers, and then take each of those parts and multiply it by the other number. When I'm done, I put it all back together again, and I'll have my answer. Although we don't expect students to be drawing rectangles for 4 times 7 for long, understanding this property helps with much larger numbers, like 4 times 743. In this case, I would split 743 into 700 plus 40 plus 3, and my rectangle would look like this. Using the area model helps me keep track of my parts and ensures that I distribute the 4 to each of them like this. 700 times 4 equals 2,800, 40 times 3 equals 160, and 3 times 4 equals 12. When I add 2,800 plus 160 plus 12, I get 2,972. As students get into more and more complex multiplication and division using an area model, it can help lead them towards a standard algorithm called partial products, and can even be used for division in an algorithm called partial quotients. Area models can be used again in the upper grades to help model multiplication and division using fractions and decimals. Although it has always been my mission to keep Monthly Math Moment down to just a short moment of your time, I recognize that this was a very fast introduction to 2 powerful models. For more information, be sure to check out the links in the description below and to continue your investigation of these tools. Next time on Monthly Math Moment, we're going to be moving away from mathematical modeling and starting a new topic. I have lots of topics that I could talk a lot about, so I'm interested in hearing from you. What questions do you have about how students learn mathematics? Be sure to comment below. Until next time, thank you for tuning in to this month's Math Moment.